Okay, the recording has started.
Oh, okay. Shall I be starting now or shall I wait till 9?
Okay. I just I just introduce both
Yep.
of you. Hi, hello, good morning, class. Yeah. So we got I think about 20 students, and today we have the pleasure to form Kerry and Joey to uh, to to show us something about to present something on uh, this the subdivision plan, and then I think I sent to you you guys all the topics that you probably go through. So yeah, I think both of them they will uh, um, this Joey and Kerry they will present, and then I think we might change the time because before that I said that there's no break until 10:30, but I think we're going to have a break like 10:45, and then um and
9:45.
9:45, and then we're going to have a like 5 minutes break, and then they're going to start again, and then we leave a session, the Q&A session at the end as well. I think we finish before 11. Okay, so yeah, now I think we hand over to Joy for you to present.
Okay.
Yeah.
We're hearing some echo. No, okay, good. Hey, my name is Joey Sim. I am an ex-Unitech student. I've graduated from Unitech in 2014. I joined Beca as part-time during the last year of my study in Unitech. I was in the Beca Civil roading section to start off, and I was mainly focusing on roading infrastructure projects ranging from motorway to cycleway. Halfway through my career, I changed to Beca development team, which focuses on land development, a lot of stormwater design and streetscapes upgrade. Kerry Overington here, who will also be presenting today, has a repository of knowledge and wisdom. He has been with Beca for 49 years and has a lot of experience in the local body engineering. His main focus are on sporting facilities land development, particularly in residential, commercial, and industrial. Kerry is now semi-retired, working on a contract basis with Beca. He has generously given his time today to share with us some invaluable advice and perspective. So Kerry and I will be doing a tag team throughout the presentation. We will answer your questions in the end. However, if you like, you can pop your questions in the chat and we can visit it at the end. So today's topic, Kerry will go through the design flow chart, what the civil engineering does, and explains the development process with a chart. The design team, people who are generally you should consult and involve for a subdivision project, step-by-step of feasibility workshop, the 3 design phases, prelim, develop, and detail. Within these design phases also includes consenting processes, where to find information of the site and for the design. Kerry will then talk through a site study example in Albany, which we had previously done, and also finally our 2 cents on what makes a good civil engineer. So hand this over to Kerry.
Oh, hi, kia ora. This is a flow chart that we did for a bid. The bid was to Middlemore Hospital, so we had one of our engineers who was good at doing graphics to put together what the process is for a design engineer. And it wasn't just civil, this was structural, and it was for a building in essence, but the process that we go through as civil engineers is this process, right? So it starts off at the top there where you've got a client there. He's the guy at the top middle with his white shirt on thinking, I want to build something or I want to subdivide something. And then he gets together a team and they go through and do what you'd call a concept or feasibility design. So that's that one through there. And once you've got that feasibility, you're understanding the client's requirements, what he aims to do, then you can proceed with the next phase of the works, which basically will be the preliminary design. So you go through the preliminary design, and that is enough to make sure that what you're doing is going to be the what the client really wants. And so through each phase, you will be costing the works and the risks, and you will be refining those costs as you go through each stage. So we've got the preliminary design. And we'll go into that a little bit more in detail. And then once you get to the preliminary design, that then allows you to get more into the detail. And it's probably at the developed design stage where a good portion of the work is done, probably in the order of 40 to 60% of the work is done during the developed design. And that's when you are making sure that what you want to consent can be built and does meet the council's and approving authorities' requirements. So because once you get a resource consent, you don't want to have to change it because something has gone wrong or something's too expensive. So you're putting your money into that phase so that when you go forward with consenting, you are in a good position to know that what you're proposing is pretty robust. Then you go into what they term the detailed design, which is more pulling things together to enable you to tender the works. And this would be done at the same time as you're consenting the works. So as the developed design has been developed and it goes off to council for approval for consent, you're then working on the detail, the much finer detail, and the contractual requirements to come up with a contract and a builder to enable the works to be done. And then we go from the detailed design tendering stage that you then select a contractor who starts to build the works. And then once they're built, it's the approval of those works back to make sure that they're met all the consent conditions, the engineering conditions, and the legal conditions, right? So in essence, that's the process. So I just felt that diagram was probably a good graphic way of indicating what you're doing at each of these phases. And we'll expand on that more later, okay? So that's a flow diagram and the normal way that a design is carried out with those preliminary, developed, detailed, it's the concept feasibility, preliminary, developed, detailed, and then into construction. And then, and don't forget after the construction, the most important part is making sure that you can then get sign off. It's a little bit like getting code compliance for a building. You have to get all these local authorities, in this case, be water. In Auckland, it's water care, Auckland Council, maybe the roading authority. And then there's the other people that get involved to make sure that they're happy too, like the iwi, forest and bird, those sort of people. So it's not a simple process, but once you understand it, you just then got to follow through. And okay, we'll go to the next slide. This slide here is from Auckland City's design manual. And it's a really good flow chart to tell you what each phase of development is. So on the top left there, you'll see it's got resource consent. So that talks about what you do to develop the resource consent. And it's got the prescribed processes. So see when you get down to the where it says S92. S92 is Section 92 of the Resource Management Act. And that's a process where if council feel that they don't have enough information, they will request more information. And at that time, the processing of the resource consent stops until the developer, stroke engineer, stroke planners have satisfied them that they've got the information that they were requesting, and then it'll start again. So when you see things like that, the S92, it's usually relating to the acts that part of the work is under. Now we'll go to the next heading. You'll see it's got 223. Now under 223, that's the Land Transfer Act, and in fact I thought it was the Local Government Act. I think it is the Local Government Act. I'll have to check on that. 223 is a survey issue, and that's when you draw a scheme plan for, say, a subdivision, and you've got certain requirements that, you know, there's has to be a certain minimum size. It may have to be a certain minimum shape, and that's when you the surveyor draws up a plan, and it's that plan, once it's consented, that the surveyor has to submit it, probably when the works are completed, to obtain what is called a 223 certificate. And that certificate says that layout of that subdivision is in accordance with what was approved. So that's just a technicality. The engineer doesn't really get involved with the 223. Of more importance is the next column, which is the section 224. Now, the 224 is related to all the conditions of consent. Now, the conditions of consent could be that you've got to plant trees, that you've got to do some offset planting somewhere, that there's all sorts of conditions. You'll find that a recent subdivision that I was involved in had 180 conditions of consent that had to be met by the 224C. So that's quite an important bit of work. And that means also that you have to have all the engineering works done, and you have to have them all signed off. So that means that the council are involved, and it's the engineer who submits a 224. It's actually a 224C, they call it. Oh, there it is there in green. And there's a 224F for unit titles. Okay, so that's quite a complicated process, and it's one that's very important to the client because it occurs at the end of the works. And if the contractor hasn't built things properly, and there's delays while he's getting it fixed, what happens, particularly in a subdivision, is there's a delay. And that delay means that he can't get title to the land, and therefore he can't get title to the land. He can't get paid for the sales that he's done already. So that's quite important, because when it becomes big blocks of land, there's a lot of money involved. So 224C is a very important step in the process, but it comes after all the works are done. Okay, next one is the EPA. That's engineering plan approval. For any works that are going to be taken over by the local government, and that would be the roads, the sewers, the water mains, you require an engineering plan approval. That's the process for getting those things approved. And that's a separate process to the resource consent. The EPA is all the engineering detail. And that's all, Joey's scrolling down there just to show you it's a lot of work until you get the assets accepted by the council, right? And you need that 224C to be able to then submit the title plan to the Land Transfer Office to get title. That's the survey plan. Okay, so the engineering plan approval is for assets to be taken over by council. Next one we have is a building consent. You've also got to get building consents for structures. Now, structures mean retaining walls, buildings, generally manholes, which are structures in the ground, are not deemed to require building consent. They're done under the EPA approval system. So, but in the other issue where you get building consents is any private drainage. So that if you're running a public system that the council are going to take over, but part of that development is to put a private line in to serve a house up the hill. It may exist, and if that becomes a private line, you need a building consent for private drainage. So building consents aren't just for structures, they're also for the drainage, private drainage. Right, and then we go to the next one, which is CCC. That stands for Code Compliance Certificate. And that's the Code Compliance Certificate is when you get a building consent, it's the approval that it's a sign-off that the building structure has met its conditions and has been built in accordance with the design. So that's the Code Compliance Certificate, right? And you normally need a Code Compliance Certificate before you can occupy a building. Okay, so that's the process, and we're providing that chart to you. That is within the Auckland Design Manual, but it does give a good example of the flow of how the engineering ties into all the requirements of the Resource Management Act, the Local Government Act, the council requirements for assets, building consents. Okay, so you can see I believe that's quite a good chart, and you really do need to read through it to understand what the process is. Thank you.
Okay, so here's a list of, so to start a project, you obviously need information of the site. So this is a list of where you can find this information. But I think I'll show you the real thing. I've got them set up in my browser. So I guess the first important thing is to identify your piece of land or property on what zonings they are in. So this is the Auckland Unitary Plan. And in here, you'll be able to see read the plan and view the maps. So if you click on view the maps, you'll see an area of your site. So for this instance, I've picked this Massey University, which Kerry will later talk about. So in here, there's a lot of information in this list. So there is some layers where it shows information, urban boundary, persistence, overlays, and all of this information then you can see a description of what they meant. So what we're interested here is the unitary plan zones. This piece of land, what are they? What is it in? They're in, sorry, what zone are they in? So if you click onto here, and obviously you can see this Massey University is under a purple zone, and here it lists a business mixed zone. You can click onto this I information, and what you'll get is information of this piece of land. Here you see, so you get your address, legal description, and then the zoning, which is something we're more interested in. So business mixed zone, and then from here, in here, you can read the plan, and then in the plan, you'll be able to see all this description and information of the Auckland Unitary Plan. So we're interested in the zones. This is business mixed zone, and then you click onto here, it brings you in here, and it describes the zone. What you can do, it gives you an objective so you can understand what's the purpose of this zone. And if you scroll down, you'll be able to see the activity table, which tells you what you're allowed to and what you're not allowed to. So you can put in dwellings, that's permitted. You can conversion of building or part of a building to dwellings, residential development, visitor accommodation or boarding house. RD is restricted discretionary. Discretionary means maybe. It could be granted or refused. If you plan on applying under the discretionary activity, the resource consent process will assess the condition in terms of the relevant provisions of the plan, objectives and policies, and also review it under the Resource Management Act. So cinemas non-compliant, so you're not to build a cinema. So quite a bit of information here and what kind of commerce business that you can actually work on under the business mixed zone. What do we have next? So we have Auckland Council GIS map, which is this. Again, I've zoomed into the Albany Massey website. In this Auckland Geo map, there's a lot of information. Again, there's different type of aerials. There's gray canvas, depending what you want to do with them and how you want to illustrate your information, terrain. And then if you move on to the next tab, you have aerials, and it will show you a list of history email of aerial. If you click on that, that's what the aerial in 2006. And then moving on, and that's in 2003 and 2004. We have assets, which is probably the most important information that we would be acquiring. So Auckland GIS map is a site contains special and non-special information across Auckland. So it's free. Most importantly, it's great. You can go into and look into where the overland flow path is by a click, and all of this information, they're all just in this website, where the wastewater is, stormwater, water. And you can also print them in PDF, the size, low quality, high quality, and then if you want to include underground services combined, it's really handy. And then you can do your measurements. You can also extract information, and then you can click onto the layers that you want to download and then put it into your drawings. So usually, and obviously you choose your coordinate system, and then you can choose, oh, sorry, I think I zoomed out. So if you do this, okay, let's just say there, you can click on type of, actually, you can click on whether if you want it in XML file or if it's in AutoCAD files. What do we have next? Oh, yes, and then there is also contours. Most importantly, it's information of council LiDAR, which is sufficient for you to work on at the start of your project when you don't want to spend money on having a land surveyor to come in and do topo survey. So this would be sufficient for initial state of the design. And there's one more thing. So Retrolens, again, this is for historical image. This would be more detailed with dates. And you can click on, so that's your Massey University site. You can click on 1998. You can click on compile your information if you're interested in. That could go up to, looks like 9440. That's just a green piece of land. What other information? So you can go into before you dig. Before you dig is free, and it will be your best friend. It is this online service which enables anyone to undertake any works to obtain information on the location of cables, pipes, and other assisting information. So it's pretty straightforward. You choose your site, you indicate where you want the information to be sent through to you. So this is a really handy site. And moving on, we've got council property files. For a fee, you pay council and you get council property files. Council property files is information on your property where you can see the history of the files, whether if there was any consent condition, the buildings information, can be anything. And then moving on, another information that you will need would be site contamination. Again, you can request information from Auckland Council for a fee. The other one, the last two one would be a limb. Again, you can request from Auckland Council for a fee. This is a common one. If you're interested on purchasing a property, limb would be a document that you would request for. And PIM, a property information memorandum, it is, again, you request for with Auckland Council for a fee. And this report contains information about special features of land and existing utility services on the property. It also provides you early notification of other required approvals, such as like resource for resource consents, heritage, New Zealand approvals, development contribution. So back to my PowerPoint. So essentially, I've talked you through with by jumping into each of the website to talk you through. And yeah, so the design team. Here's a chart. You can see the consultants that are required to be involved for a subdivision project. On the left side of the flow chart is what I would call them the initial work team, urban design to design the overall site. Ecologists, they perform contamination report. Arborists, they report on existing trees. The report would have information such as the type of trees, if native, their age, size, and condition, and sometimes with some recommendation. Planner, they analyze building projects, for example, for their potential impact on the environment. They seek ways to mitigate those impacts while following the environmental regulations and procedures. Land surveyor, they perform detailed topographical survey information for the team on the right side of this flow chart to produce the works. So architect come up with architectural plans and report. Geotech, traffic engineers for traffic information. Geotech for soil condition, and civil engineering, that's us, cost engineer to come up with the total budget cost for the client to make decision. So once that design phases are all done, move on to construction, then we have the construction team. We have the project manager, engineer to contract, engineers rep, and then the representative from each discipline, if required, that should be there if there are any RFI, which is request for information. If they're, well, sometimes they questioned, why is it here? Can we do this because this is cheaper, etc. So, Kerry?
Yeah. Right. Okay, so Joey's just explained to you how you need to gather information initially, but the next step is to get the client will get his design team together, and then you need to look at what the feasibility of this project's going to be. And often you'll find that the client has he has specific requirements, what he wants to do. And this is a really interesting phase where and normally we would get a team together like that team on the left-hand side of your screen with all those people. And then you go into a workshop and you work through to discuss with the client, and it's important that the client be there, you discuss his objectives. What does he want to do? Does he want to build, does he want to subdivide land and to build houses on that subdivided land and then sell the completed project? Does he want to build apartments? Does he just want to subdivide the land and sell it? So you need to understand his objectives. And then the next thing to do is to identify the site constraints. Now, the site constraints, and we'll go through an example on this, on what the sort of constraints can be. But I was looking at that flat bush site that you were doing an exercise on. That's very flat. So what are the issues with a flat site? There's no stability issues, but it does have a watercourse running down through part of the land. Okay, so how does that affect the development? Then the other constraints are there services to the site? How are we going to connect power? How are we going to connect sewer and water supply? All of those things. So you look at identifying the site constraints. Then the idea is then to develop alternative layouts and then to assess each of those. Now, as I said, these are usually done in the workshops, and I would suggest that there's only, it would only be 2 or 3 workshops, but they're interactive. So everybody comes along prepared based on their own expertise on what the constraints are, what their thoughts are on how the land could be developed. Listen to the client, and then all together you sort of come up with a design. You consider the consenting requirements. Consenting is a long process. It's an expensive process, and there could be options. For instance, are you going to go for the minimum lot size and maximum earthworks? And that could have an impact of some adverse effects on filling watercourses or something like that, right? So you consider the consenting required and their options. Then the idea is to come up at the end of this exercise with an agreed layout that the client, that everybody sort of agrees is, a good compromise or a good way to proceed, and the client agrees as well. So then you can cost the selected option. And you don't only can select, you cost the works that has to be done, but you also include the risks. And firstly, you've done virtually no design, so there'll be a contingency risk. And that contingency, because you don't know all the issues, would be in the order of 30%. So if it was a $100 million job, you would be adding $30 million as a consent. So, that's the sort of order that you would do at that sort of stage. And then you would also cost the risks. And if you know what, we're going to say, hey, look, we're not sure if all of the site can be serviced by the existing sewer system. We may have to put a pump station in. So at that stage, you would allow a cost for a pump station. So you look at all those sort of risks that you have. And not only that, so you're looking at the cost to develop that site along the lines of the layout you've agreed. And at the end of that process, you also decide what's the program going to be. If it's a big site, it'll be could be several years of development, right? And that decision on the program will be client driven, because he's the one who's having to fund the exercise. So he has to have the money to be able to pay for the works. And usually what happens, if it's a large development, they'll do it in stages so that they start to get an income stream partway through the works. And once the program's decided, then it would be over to, usually this is driven by the civil engineer. The civil engineer would then produce a report that pulls together all those discussions you've had in those workshops, and the report would then include the costs. So this process will give buy-in by all the parties, because all the leads are there giving their inputs. So, if anybody was really unhappy with the site, that would have been with some aspect of the layout or whatever, that would have been decided during that process. So it gives buy-in by everybody, and it provides the basis for the project to proceed. And so that means that the client can continue to look at his viability. This process won't tell him that what to sell his lots for, but it will allow him to now go and seek other advice so that he can look at the viability of his development. Right, and it also then enables conversations to be initiated with the approval bodies. And it also establishes the need for the further investigations that are required. So you've looked at the risks, and those sort of further investigations will be geotechnical, they could be ecological, they're looking at the health of watercourses, could be an arborist. So all of those issues that have come up will be part of the assessment done and will lead into doing the further works and identify the issues that need to be addressed. So that's the feasibility stage. Typically, I can remember doing one not so long ago for a 40-hectare site. We spent 200,000 on that design workshop feasibility to get that report. That would have represented probably maybe 1% of the fees that the client would be having to pay, right? So it's a fairly small percentage of the fees paid. So, but it gives you a way forward. So we'll go to the next slide now.
Okay, I'm just gonna touch on the boring stuff. Here's a list of standard and guidelines that civil engineers refer to do the design. So Auckland Council Design Manual. This manual gives you a good guidance and also explains the importance of a good design. So this guide sits alongside with Auckland Unitary Plan, which I've already touched on. Auckland Transport TDM has recently came out with a new manual. Auckland Transport TDM is the new manual. They've recently came out with this new manual in replacement of their previous technical manual called ADCOP, Auckland Transport Code of Practice. So be sure to refer to the newer design manual because you can still find the old manual online. For the new manual, just search for Auckland Transport TDM. The design manual has design information related to Auckland transport assets such as like footpath, how wide footpath should be, and for wheelchair, bus stops, curb and channel, traffic islands. So for water care has a code of practice for water supply and wastewater, which we heavily rely on when designing both of these services. NZS 4404 Land Development and Subdivision Infrastructure is your handbook for subdivision. It covers the general requirements and procedures for land development and subdivision, approvals for design, construction, earthworks and geotech requirements, and all the other related services. Building code, E10 talks about stormwater management area, flow 1 and flow 2, where you will need to identify whether your site are in the zone. E1 building code talks about surface water in relation to building. This standard provides a method of verifying that a proposed building flow level shall meet the requirement. NZS 4509, the New Zealand Fire Service Firefighting Water Supply Code of Practice is, we'll touch on that later. So these are your basic standard guidelines that you would refer to when you're doing the design. So the design process, the preliminary design phase. These are the following tasks to be undertaken by the design team, which we have previously mentioned in design team chart. So the detailed topo survey by land surveyor, ecology assessment by an ecologist, geotech by geotech, arborist on trees, contamination investigation, historical site study by environmental planner. So while these investigations are being performed, discussion shall be held with the council on planning and the roading and any stormwater issues related to the site. You should also have discussion with water care and the other services providers too, to assess the existing capabilities of their assets. During this process, during preliminary design process, client would be interested to know the estimated cost. So that's when the cost engineer comes up. The outcome from this investigation will have modification to the original concept during concept plan developed during the feasibility study, a preliminary set of drawings, and an updated budget cost estimate. Some risks will be better understood, therefore increased or decreased, and the contingency sum may be reduced. So say 20 to 20 or 25%. So depend on the size of the project. For a smaller project, a resource consent can be applied first using prelim design. The develop design. This is the stage where all the fun stuff happens. The design and information provided needs to be sufficient to meet consenting expectations. So that's quite a bit of information you need to prepare, and whether or not the items required to be consented can be achieved. So what are the fun stuff? The division roading and road layout, there are quite a bit of thinking there, as you would want to maximize every lot, every subdivision lot that you've planned on. And you also want to make sure the lot are positioned such as north facing. If there are any contamination issues, this stage, the issues should be sorted. The amount of earthworks required to be determined. We use software such as 12D and Civil 3D to grade the terrain, and from there we could spit out the amount of cut and fill required for the site. I believe these two software are the ones Unitech teaches. And sediment controls, you will need to know already how it should be handled. Usually the sequence of work shall be recommended, the type of erosion controls, usually prepared in a report and a set of plans. Geotech assessment, if the site required retaining walls for ground improvement. If no retaining wall, I guess you may have a smaller geotech assessment report. Staging of works, if it's a big piece of land, you would want to split the work into stages. If any ecology issues, flora and fauna issues that shall be resolved, it could be removing water course and offset measures. Stormwater detention, quality treatment. Stormwater is a big portion in the resource consent approval. So you would need to identify the type of stormwater treatment required. By our full details, by now you should know where your runoff discharges off to, and all the services required for subdivision, such as wastewater, water, power, comms connection. So once you've completed the developed design, a consent application can be made to the council. This application would pull through together all the specialist assessment, the planning requirements, and the engineering aspect into a report title called Assessment of Environmental Effects, which we call it AEE in short. So AEE is a written statement which identifies the effects of your proposed activity on the environment, so we can assess the likely impact of proposed. The effects can be short-term or long-term, positive or negative. So this is a document that council will assess. Consenting approval can be from 20 working days and up to 6 months or more, depending on the information requested by the council. I like to jump onto my drawings that I would share I've recently done for develop design to give you an idea how much information you would need. This is not, we're not up to the resource consenting stage yet, but this is for costing. It's gone for costing and further review and coordination with the architects and the client. So after we get the consent, costing back and review back, if the cost is too high, we will have to review the design and see what we could reduce and minimize and finalize. So this is a site. So I'm just going to talk through the information we've provided. So we have the general notes and legend. We have topography survey information, which what land surveyor would provide. Some contour, assisting contours, chambers information, curb and channel, light poles, and then you will want to show your assisting services information. So it is a busy site. There's a lot of information. Oh, sorry, I should introduce this project just quickly. This is a project on Current Street, just near the West Haven Marina. This is State Highway 1 heading towards the bridge. So this is what we are upgrading this area into a nice public realm so people can hang out. So where was I? So I was up to services, and we've got pavement and surfaces. So this is the design grading that we've graded, and pavement information. So you would pave surface and pavement. As a surface would come out for what would you would get, so you can understand how much earthworks that involved. That's a fair bit of cost in there, and pavement is also quite a big amount of cost. So you will want to identify that piece of information, what type of pavement. Sorry, I'm just showing you the first page of the project instead of going through all of it. We have the three waters. So in here we have proposed put in a swell that is next to the carriageway as part of a low impact design approach, which is something I will touch on for the stormwater bit. And then we have cross sections. We also have some long sections, since we've got all the information already, as said that we should have the pipe outfall discharge, where water should be going into and at what level. We also have a bit some information, because this is a 90% developed design. We have some details for the cost engineer to cost up. These are big items such as the light poles, swell details, garden bed, pavement information. This is the garden bed. Yeah, so these are the information that I've provided for this 90% developed design for this job. This is not a subdivision, but I thought I just want to show you what kind of information and drawings that you would want to prepare for the design stage.
And these would be fairly typical of a developed design, which is quite detailed, as you can see.
Yep. And just moving on to the detail design. So the detail design is the phase where the design is refined more so from what you can see, and then we're just adding more information and then complete with more coordination with other disciplines. Yeah. And then from there, you have your plan, specification, and estimates are created. This phase is where the full cost of the project is identified. Then you'll have your drawings to be completed with specification, which is really important. Conditions of tendering, conditions of contract. The tender documents will typically include a schedule of price, health and safety requirements, quality assurance requirements, conditions of consents, and condition of the contract. Once tender documents are being prepared, and engineering planning approval will be made to Auckland Council. Again, so if you have any structures such as retaining walls, a building consent application will be required. So if your site is along the state highway, you might need approvals from Waka Kotahi, which is previously called NZTA. Okay, so that's the...
Can I just interrupt there for a minute? Just the at the end of that design stage, it would be normal to have a contingency sum still. And see, I'm focusing on the money here because that's what the client does. You'd normally at tendering stage allow a 15% contingency. And you might say that's quite a lot, but we find that when you tender the works, the tenders can come in a range between, if you've got 4 or 5 tenders, there could certainly be a range within 15 to 20% of the prices actually tendered. So you can see that, and of course, you've got a contingency sum because a lot of the work is going to be under the ground, and you don't exactly know what those ground conditions are. So typically, when a contract is let, it would most bodies like NZTA or councils would have a 15% contingency still within there, because there's nothing worse than kicking off on a project, finding out there's something that hadn't been discovered, and having to go back for more money, right? So, yep. So costing and the costs are pretty important.
Okay.
Okay.
Cool.
It's now 10:02. Joey, do you think we should break here?
Yeah, Edward, what do you
Yep,
think?
yep.
Well,
I think we can have a 5 minutes. You want 5 minutes break?
Yeah,
Yeah, that'd be good.
I think we
Okay.
took a bit more time than
Yeah.
we
Okay.
practiced.
So yeah. Okay. After we start and run it, and then at the end we question answer.
Okay, so we'll be back in 5 minutes, okay?
Okay.
Okay.
Let's keep the recording. Let's
I'll
continue.
get a
to run.
coffee.
Okay.
Okay.
Oh, Joey.
Okay. We have a break for 5 minutes.
Joey, I think we're just a little bit over time.
Yeah.
So
I might go swiftly go through the storm my bid. I don't have to. I mean, I can talk quicker.
No, I think we're okay because
Yeah.
we've got a little bit of time at the end as well. Like we're just making sure that we cover all the topics we have.
Yes. I think it's very informative. A lot of things, because even I'm the we have classes we have class every week, but I think I don't go into so much detail. So yeah, so I think it's really good that we after that I can send this is it this one you're going to pass to me?
Yes, I will send the PowerPoint, but I'll have to remove
Okay, I
the
will
Beca watermark first.
okay, sure. I
Yeah,
run
yeah.
it to the Moodle for all of them to see.
Okay, yeah. Because we did prepare the PowerPoint in a way that they could look into. That's why we actually had the links of where to
Yes.
find the information and things.
Okay.
Yeah.
Mm.
Okay.
Yeah.
I'm just gonna jump back out and then I'll come back in.
Okay, sure. So it's 5 minutes.
Yeah.
Okay.
I think I've changed. I'll just mute it now.
Yeah, Joey, it's quite informative. I think
Oh, great.
yeah.
I
I think
just
you
realized we've only gone through 14 slides and we've got 62 slides.
yeah, but I think just see what you can
Yeah,
do.
yeah,
Yeah,
we'll go from there.
yeah. I think that the pace is quite good.
Oh,
Okay.
great.
Yeah, yeah.
Okay, I will share my screen again. Have you guys talked about this? The rainfall?
We talk. I think roughly all the thing we have talked about the stormwater, wastewater,
Yeah.
and then the road not really road. I think because I'm not going to cover that much because there are a lot of them that study the highway
Oh,
one.
right. Yeah.
Yeah, so
I
they cover
think.
quite a lot. Highway two, and then I just
Yeah, I think Unitech does carry quite a bit heavier on the highway side.
yeah because
Yeah.
stormwater we cover quite a lot in the highway one as well. But
Oh,
not all
okay.
the
Yeah.
yeah not all the students they some of them they didn't. I
They'll
think
have
they
to pick
didn't.
the paper, is it?
Yeah, because it's a compulsory paper, and
Okay.
yeah, so the stormwater I think they should be able to do. I think, but I think the council how they do it all the bylaws the I think the code of practice I think that would be good because we have to follow the all the code of practice.
Mm. Okay. Cool. Kerry,
Yeah, I'm back again.
that's you, Kerry.
Oh, it's me.
Yeah.
Oh, next slide. Okay, roading design. Okay, so look, these are just some aspects of what you should look for when you're doing all of these phases of the design, right? So the roading design, that'll be dictated by the topography, by the urban designer's concepts of how the road will look, and will it have a central median? Is there going to be tree planting? Those sorts of things. And also the requirements of Auckland Transport. They're very specific in their requirements for different classes of road. For example, they have local streets, principal streets, or arterials, and it's those requirements which will dictate the carriageway widths, the parking, the berm requirements, and you also have limitations on grading. For instance, in a local street, council would like 1 in 10. The maximum you can have for any street is 1 in 8 or 12.5%. That's pretty steep, right? Also, intersections must be safely designed so that you've got adequate lines of sight, and so that you don't have trees obstructing lines of sight for other vehicles approaching the intersection. And then there's the requirements for rain gardens, street signs, trees, bus stops, cycleways, and all of these need to be considered in developing the road configuration. Okay, next one. Earthworks and stability. This was a project that this was one that Beca did. It's in fact the Pacific Heights development, which is in Orewa. Now, the yellow and the red are depth of cut contours. Just the distinction of the yellow was that all of that was stage 1, and the red is stage 3, and stage 2, and the area through the middle is stage 3. So the cuts and fills, there was cuts in the yellow and red of up to 8 meters deep, so that's quite significant. This was a very steep site. There was the green is fill, and the fill depth through there's a gully running up through the site. It's that blue line running up through the middle. There was fills up to 16 meters deep. And if you look at the top, the left-hand area, top left-hand where there's red is, that was RL 90. And down the bottom of the site where the stream exits to the next property, that was RL 10. So there's 80 meters of fall across the site. So that's a pretty steep site, right? It had ground slopes of 3 to 1, had some slips within it that had to be looked after. That's old ground movement. And so that site was developed with lot slopes. That means the slopes across the site, each development site of about 1 in 5, and that's what you need for access off the road, with some slightly steeper areas at the back of the sections of maybe 1 in 4. Maximum road grades of 1 in 10, as the council requested. Retaining walls kept to less than 5 meters. And to achieve that, part of that central stream, the top end, where the green, the big green area is, there was watercourses in there that had to be filled in to achieve that balance of, the earthwork shapes that were looked at as being desirable and keeping retaining walls to a minimum. A previous scheme developed for the site had a 16-metre high retaining wall, about 150 metres long. It was done by another engineering company. And when they had that costed, all the walls they had costed for their stage 1 works, which was basically the green area there, green and part of the yellow, the retaining walls themselves were costing 20 million. So that was just, a 16-metre high retaining wall is a 5-storey building. It's not appropriate for a residential land, right? So the compromise here with council was that, and council would have to take over that retaining wall. The compromise was to fill part of the gully to reduce those slopes, which was, and that was consented. And the earthworks shown there were a balance of earthworks, right? So steep sites, slips, watercourses, all came into the thinking on this, on how that land was developed. Next one. Contamination, well, on that site, and we'll just go back to the previous picture, you'll see in the Joey's just showing that area through there, which has got a thin red outline. That was a landfill. That was developed by the East Coast Bays Borough Council back in the 40s and 50s as a rubbish tip. There was a gully down through there. And that had a lot of consequences on contamination and stability issues, right? It was up to the rubbish tip itself had been investigated and was up to 10 meters in depth. And what had to, as part of the consenting, there had to be a leachate collection system and a methane gas protection system, and that meant putting perimeter drains around the existing landfill. It was covered over further, and that meant settlement. Council in the end wouldn't take over the bit of roading that goes through the toe of the landfill, and that still remains in the private ownership of all the sections within the development. So again, contamination is an issue. I think that's all I'll talk on contamination, because we're having to move a little bit faster.
Okay.
And you can read the words here, because they are important, that where you check on things like the the aerial photographs and things to look at the historical use of the land. That's the purpose of these older photographs. What was the land used for? Okay, next one.
Okay.
And now we're into stormwater.
Yep. So on to stormwater. Okay. So I would like to start on the first principle of stormwater criteria. If you understand this, then you could have a better understanding on the documents and guidelines. These are commonly used terms in the guidelines. So when you're managing stormwater, the method we use to manage it really depend on the size of the event. What you got here on the y-axis is the depth of rainfall measured in 24 hours in millimeters. And then the x-axis calls for the retention, detention, first flush. For the smaller rainfall events, uses volume control method, essentially things you would do to make your water disappear, like reusing them, infiltration into the ground, slowing it down, holding onto using an orifice, that will be the detention. First flush is what I call it, the day-to-day stuff, managing stormwater quality. That is your stormwater treatment picks up the contaminants, hydrocarbons from the road and treat them. Substantial storm as in 2-year and 10-year event rainfall. Your primary network should be able to cater this rainfall. Primary network could be the pipes or open channels. 100-year event rainfall usually used to calculate overland flow paths and freeboards and floodplains. To give you an idea of how much 100-year rainfall looks like, it's probably a month ago, if you remember, where Kumio area got flooded, which had to evacuate 50 over homes. That night, NIVA, which is the National Institute of Water and Atmospheric Research, recorded 208 mil of rainfall. So gives you an indication of 200 mil rainfall is that much water. So we've talked about the principle of stormwater criteria. Here I want to touch on what and why. So retention, detention purely to help minimize stream erosion effects by capturing runoff. So for reuse purpose, infiltrating ground, to minimize stream erosion. Quality is to remove contaminants. Again, it is to improve stream health. Primary peak method is to convey through networks, that is pipe and open conduit. This is for the serviceability and avoid flooding. Secondary to convey overland and set floor, bridge, and culvert levels. This is to protect assets from flooding and general safety. So how do you capture runoff for reuse? So retention here is what we do with using the methods such as having tanks and used for toilet flushing, irrigation in roof tanks, or creating surface for runoff to infiltrate the ground. Detention is the method of where you capture the runoff, store them, have a slow release of 24 hours period through a calculated orifice. So detention could be a swell, wetland pond, detention pond. And the quality method is to remove contaminants. We usually measured in total suspended quality, the TSS, of minimum 75%. This method is to minimize contaminated accumulated from the road surfaces. The contaminants usually gonna come off at the start of the storm, so you want to treat them at the start, and the rest you can bypass. That is just to minimize the size of the treatment device, because if you want to treat all of the stormwater, that would be quite a lot. For primary storm in Auckland, we usually use 10-year event rainfall to calculate the capacity for gutters, inlets, pipes, swells. This design also, you got to attenuate to match pre-development peak flow. For secondary flow, we would use the biggest event, that which is the 100-year rainfall capacity to calculate overland flow path with freeboard. Also, part of the calculation, we are to assume pipe blockage depending on the size of the pipe to suit the vulnerability of the asset. This is an example of stormwater design criteria for a project that Beca worked on. This is a table created to capture all the inputs you would use for your calculation. It's just, for me, it's just really easy that you could refer them, and then when people ask you, oh, what's the rainfall? And you're like, this one. So rainfall depth is one of the most important information for your calculations. So where to get rainfall data? You can go to the website, search for TP108 rainfall map. There is a series of rainfall map for 2, 5, 10, and 100 year. There is also a website called Hertz NEVA where you can retrieve rainfall information. That's where this measurement for the Kumyo tells you 208 mil. Depending on your site, it varies where you pick this rainfall. I usually collect both rainfall data from TP108 and Hertz to make a comparison. You would want to be careful not to be over conservative or underestimate with the rainfall data that would cause oversized or undersized pipes and treatment devices. I'm just going to jump onto my browser and show you the maps and the NEVA website. So this is TP108 10-year map. So you can see for the 10-year, it ranges from 110 to 210, depending where your site is. So you can see North Shore is a lot more higher. And then another example for 100-year. This is a 100-year map, so it ranges from 150 to 310. Again, North Shore seems to have a higher rainfall event. And to NEVA, again, so I've picked on Massey University site. So this website gives you, I guess, the most updated rainfall data compared to the TP108 map, because that was dated in 1999. So from this website, you can get the depth and the intensity. For this instance, we're interested in the depth. I've already generated the report. There is different scenario to look into. I won't go into this detail. This is a whole lot of another level of information, but ideally you would want to pick on 100-year event, 24-hour, and then that would be your answer. And then you put them into your table. Just jumping back onto my PowerPoint. Okay, so where am I? So this particular site, which is the Carrington backbone which is next to the school, the uni. This particular site example is not under stormwater management area control, which we call SMAF. This is a control that seeks to protect and enhance Auckland River stream and river stream aquatic lost my word, aquatic biodiversity in the urban areas. So, and then moving on, the primary stormwater system includes both open and closed. Sorry, where was I? Yeah. Well, oh yeah. So 100. We're in primary storm network. System include both open and closed conduits and are designed to cater for the flows generated by the event specified. So in this case, 10-year event rainfall. Secondary stormwater network system, as mentioned, we use 100-year. So building flow level is one of the first thing you need to calculate and find out. So this information you will need to provide to the architect. To find out the building flow levels, you will need to calculate the floodplain and overland flow path of the site. From there, you can add on the freeboard additional height. I've got a diagram later to explain this freeboard. So under the NZS 4404 and building code E1 is used to apply different freeboard levels. So 0.5 freeboard when measured over 100-year event floodplain, 0.3 freeboard measured from 100-year event overflow path. So with all this information, where do we go from with all these inputs? So we use softwares and spreadsheet to calculate our design. We use HMS to model hydrology, HEC-RES for hydraulic modelings. We've got IDES and Civil 3D and 12D to output drawings and log section. This is in particular for stormwater. This diagram indicates how to measure freeboard, which I previously mentioned. The minimum freeboard for overland flow path as per the New Zealand Building Code E1, using the flow generated by 100-year rainfall depth. In this instance, the flood level is measured in the relative to the datum. From there, you add 0.5 meter of freeboard. In this case, it is a habitable dwelling. That's how you get your building floor level. There are other freeboard requirements depending on your different situation. That is, if you're habitable dwellings or commercial and industrial, and if you're non-habitable residential. So they all have different measurements. I think the commercial ones are 0.3 meter. 0.3 meter freeboard, and then non-habitable is 0.2 freeboard. This is an example for Christchurch site. This is the assessing property. This red line here shows the 5-year storm event, where it should be the curb height. The calculated 10-year storm event level. And this is the proposed new building, and with the calculated 50-year event rainfall, you plus on the freeboard. In this case is 150 mil. This is Christchurch. So note that they use 50-year flood event. So it is something that you want to check on your local guidelines if you're working on different regions. We talk a lot on just using the Auckland regulations. So this image just illustrates where you apply different freeboard from waterways, freeboard from overland flow path. So you can have a look when you have the PowerPoint in details. The treatments. So one of the common stormwater runoff treatment is from rain garden. The runoff enters a rain garden through vegetation layers at the surface before it soaks into soil media. You see a lot of this, I believe, in shopping malls and new development. It is important to create a low point for runoff to flow into the rain garden. This rain garden, I think on the left here, looks a bit dodgy in terms of the low point created. Like, it would be interesting to see on site when it rains, because I can see this gradient. I think it grades into this channel and comes in here. So it looks a bit dodgy to me. All right. So this cartoon illustrations to show why it is important to treat rainwater, especially on the road carriageway. So you can see all the pollutants on the road, on the footpath. Contaminants will be washed into the rain garden. It gets filtered. Here, draining out the filtered stormwater discharge into streams or water body. So clean water equals to happy fish. This is a section of rain garden from Auckland Council Design Manual. It has 6 key components. The type of soil media needs to be approved from Auckland Council, usually approved supplier. So depending on the underlying subsoils, stormwater may be then infiltrate to groundwater or be collected and piped to the discharge point. The ponding on the surface of the rain garden is called live storage and is designed to dissipate over a period of 24 hours as function of media permeability and evapotranspiration rates. The type of plants, you would want to plant hardy plants to suit extreme wet or dry condition. the under drain system for the pipe to go into the network. So the location of rain garden usually includes roadside verges, traffic islands, parking areas, and sometimes around existing catch pits. So you've got an outlet point. They're usually incorporated as part of the landscape design. Swell, I'd like to touch on a little bit on swell. The function of swell is vegetated with flood tolerant, erosion resistant plants. The design of grass swell promotes so you can conveyance stormwater at a slower control rate. It acts as a filter medium, removing pollutants as well, so allowing stormwater infiltration. The typical location for swell is next to impervious surface such as parking areas and roads, and potentially to take up the place of a curb gutter system pipe. So that's what I did for the project that I showed for the 90% developed design. So we had swell next to the carriageway, no curb, so you can just go into the swell and get treated, and then use the pipe system and go into the sea outlet nearby. So it plays quite an important role to soften the area. If you've got too much concrete and asphalt, it looks a bit it's not nice. Wetland. Depending on the size of your development, wetland can be a good method to attenuate and treat your flows. They play quite an important function, including attenuating flood flows, water quality treatment, support of aquatic plants and wildlife. It just works as a detention, fine infiltration, and biological absorption, and remove contaminants at the same time. So the wetland design guidelines can be found in Auckland Regional Council TP10. Yeah. And then stormwater filters, some examples of proprietary devices to treat runoff, such this is storm filter. This is a treatment product I often propose for installation when other options are not available to treat carriageway runoff. It's you can put them in a standard manhole depending on the size of the catchment area. If it's just a small area and then you want to treat this carriageway runoff, so it's a good device. The image on the left is an example of stormwater filter vault for a very large catchment. So you can see each of these filters put on, and water flows in and it gets treated. Here are just some examples of water tanks. Again, depending on the size of the water to detain, it comes in various sizes to fit its purpose depending on its location. So these water tanks have ability to store water, reuse, or slow release.
Now, Joey,
yep.
you're using up all our time. And I think what we'll do now is I think we should skip the water and the wastewater and the services, because they're all written there as, it's self-explanatory.
Yeah.
And I think we should go to the example now that we were looking at.
Yeah.
That feeds into their project that they're doing, right? So if you could go to the Unitech one, because we've only got, theoretically, we've only got 20 minutes, and that should include questions and answers too. So if you could go to the Massey site, that's that one.
Okay.
And I'll quickly go through this so that, if we can go back to the others, we will, but let's see how we go. Okay, next one. This is a site in Albany. It's the Massey University, which you may or may not know. It's that's the sort of zone that we're in, and in the middle of that picture is some spare land that is that was thought of by MBIE, that the Ministry of Business and Innovation, where because of our lack of housing in Auckland, they were looking at surplus land related to any government institution. So let's take the next picture. Okay, so the area outlined in, or areas outlined in red there were areas of land that the universities say they probably won't be using in the future. So I split that into, so we were looking at this on behalf of MBIE, and I split it into four areas. The southeastern area, that's the bit to the right, that tongue of land. It's got very poor access, in that Bush Road is the road to the lower right. It's very close to a major intersection, and that land probably is best suited for the university to use in the future. The southern area is that whole area of bush. That would be so difficult to consent, right? Because the area outside of the red line to the west and south, north straight up the page, is what they call the Fern Hill Escarpment. And I think there'd be a hue and cry if any of that bush in what we call the southern area was disturbed. Then we have the central area, and that is an open paddock. That is a nice parcel of land, and we'll talk about that. That's the central area. It's open grassland. And then there's the area to the north, which is that smaller parcel of land fronting onto Albany Highway. Okay, next one. So this is just an example of the information we gathered. That was a 2008 aerial photograph. You can see that the university is under construction, and that virtually there's not a lot of change to the land, except that the area in what I termed the northern area fronting Albany Highway, that was set up there as a yard, because they were about to develop the Albany Highway and to upgrade that, and that was going to be used as a contractor's storage yard. Next one. This is the LiDAR. Now, I was going to ask you, Joey, what does LiDAR stand for?
LiDAR stands for light detection and ranging. It is
light detection and ranging. Okay,
yeah.
that is information is gained by flying over an area, and it is pretty accurate. However, it is dependent on things like the length of grass. Obviously, on hard stand areas, it's pretty accurate. Now, when I say pretty accurate, probably accurate to within 25 millimeters or so. However, if you have a grass paddock and the grass is half a meter or 300 or 400 high, then it won't pick up that exactly. And in bush areas, although they're pretty, you can see that the contours are pretty detailed in that bush area. What it does is it filters out any shots that are hit the top of trees, but it actually picks up the ground level below, where it can see the land. So there's a filtering system for that. Okay, so that's the LiDAR, and that showed the area of the site. Here's another example of the, well, three things. There's the streams and watercourses. There's the floodplains and the flood-prone areas, and overland flow paths. Okay, now you can see through that green area in what we call the central area, there's a small stream running through that, with a larger stream to the east and a much bigger one to the west, below the Fern Hill, over through there. Yeah. Okay, so this is the bit of gathering of information before you do anything, right? Next one. Right, this shows the sewerage in the area. There's not, it doesn't specifically show how the university is serviced with sewer, because that's private, okay? But it looks to me as if it probably goes off to the southwest or southeast. There is an existing pump station where Joey's indicating that now. So and the land all falls to that low point. So the land can be serviced with wastewater. The bigger red lines there are trunk sewers coming down to the pump station and a rising main going away. I don't know which direction it goes in. I think I'm not sure. But that is a pump station, so that shouldn't be an issue. This is the next one. This is the stormwater supply. You can see all the green circles to the left there. Those are all manhole serving that residential development through there. You can see the water courses in green, and there's pipelines all through there picking up the roads. Discharging from the side shouldn't be a problem because you'd be discharging to water courses. Okay, next one. And this is the water supply. There's mains right past the area in terms of the big blue line you can see going along Otia Valley Road. Sorry, not Otia, Albany Highway. Okay, next one. Okay, these were a couple of pictures we took just to show what the site looks like. This is the northern site, and that's that smaller parcel of land to the north. It has access already built. That's a signalised intersection just straight in the foreground. And further down the road, just beyond where that car is on the left-hand photo, there's another set of traffic lights that again gives access into that site. The right-hand photograph is standing at the top of the hill to the left of the left-hand photograph, looking back down. That's Senior College in the distance there, and that shows that block of land. And so I think we can say from that it's got really good access. And you can see that photo was taken at 7 o'clock in the morning, and it's north facing, and it's starting to get the sun already now at 7 o'clock in the morning. In fact, being north facing, it gets the sun most of the day. So that's quite a nice site. Next one. I think the blue patch on the bottom there sort of shows where we're looking up into the site. And that's the central gully, that small watercourse that went up through there. And the right-hand shot is along the top of the ridge above the northern area. Okay, so let's go to the next one. This is just to give you a feel for it. This is standing from the same point, but looking towards the southeast. And that's the little ponding area on the right there is looking up and into that central watercourse. And then further over on the left-hand side, you can see there's a bit of a ridge, and then it falls down into a southern watercourse. Okay, that's just to give you a bit of a feel for it. And that is a access road into the Massey College. The first one is looking towards the east, looking towards the west, where a road would come off and follow up into that paddock you can see in the distance. And then the one on the right is where it exits onto the Albany Expressway. So that's the sort of initial walk-over assessment you'd have. You'd walk over the land, and let's go to the next. Okay. So what's the so I'm being very brief here because that's just the sort of information you'd get, and then you'd look at it and say, hey, what are the constraints on the site? What are the good points? So the land off Albany Highway has good access. The site is going to be sunny most of the day. The trees above should be left. There are a lot of natives in there, as well as gums and things. They're on the south side of the site, so they're not a shading problem. And the site would suit high-rise development, 4 to 8 stories. So it's good for apartments or even a retirement village, something like that, right? So it's a small site, good access, good positioning in terms of the sun, and good access to transport and shopping centres, etc. Okay, so let's go to the next slide. And look, all I've done there is sort of said, hey, that's the area. It's 2.5 hectares. It could take several blocks of buildings with access at the 2 traffic light entrances. And there's a potential for 300 plus apartments through there. So 300 plus apartments is at least, it's in the order of 800 to 1,000 people could be living in that area. Okay, next one. Then we have a look at the central area. That's a bigger site, 7.1 hectares. Now, the site access is an issue, and as is the central watercourse. But that central watercourse peters out just before that southern boundary. So it's more of an intermittent stream than a permanent stream. You would have seen there was a bit of a pond at the bottom end, but that I think is an accumulation just of groundwater coming down through there. The access, there's that existing road to the east, and that is nothing wrong with that road. It could give good access into that site by running up, by continuing it up through across the watercourses and up into the area. So central watercourse, always an issue. Council do not like filling any watercourse, and if you do, you've got to pay for it by an offset cost. It could be money that they go and use elsewhere, or something that you do to enhance the area. So the only practical access is to that site was from the Albany Expressway, as I pointed out. And although the watercourse looks intermittent, it does look intermittent. It could be filled. That would give you more development opportunity, but it would be a significant consenting issue. And the option is to leave it as open space. But if you leave it as open space, you then got to talk to council. What do they want another pocket reserve? And that's always an issue too, because they're, I mean, the planners would like it because it gives access to people living in the area, but the parks people don't particularly want all these little pocket handkerchief type reserves because they're expensive to maintain. So let's go to the next picture. The things you need to think about: is it in a SMAF area? That's a flow restricted area. I haven't determined that. You could enhance the pond on the central watercourse to provide detention if you had to. Wastewater, you need to check the capacity with water care. Is there likely to be any contamination? Probably pretty unlikely in that area, but you'd need to check the historic uses. If you're leaving the central watercourse untouched, the earthworks would be relatively minor. The access road would probably need a bridge or culvert across the watercourse, and a bridge would be best, but expensive. A culvert, you've got to think of fish passage and things like that. So that's where the ecology comes into. And we often, when we pipe watercourses, are required to provide little rills or ridges within a pipe so that fish have a chance to swim through it. And they use the little blockages as when I say blockages, the little the restrictions within the pipe where water ponds, and they can rest in those areas, right? So, yep. So next one. And there was an idea we had that could, and this is just a hand sketch again, that's how this land could be developed. Now, there's been a bit of a compromise here. We've filled the top end of the watercourse, left a good lot of it, and opened that up into what would be a playground. And in that 7 odd hectares of site, you can get about 97 lots. Yes, and then you'd have links through to the Fernhill escarpment and the areas you left in bush. So you can see that's just one thought, right? There'd be other options on that. So that's the potential layout of the central area. Now that's all I wanted to say about that.
Yeah.
But the next one, the next slide, and we're coming towards the end. This was we thought we'd include this because what makes a good civil engineer? And that made me go around my colleagues and ask them. So I went around senior people at Beca and said, what makes a good engineer? These are the responses, right? And you can take whatever you like for this. This These I thought were all good ideas for what makes a good engineer, a civil engineer. So he's able to deal with complex issues. That's one of the requirements of your professional interview and things. They do assess you against being able to deal with complex issues. A good engineer has a good all-round knowledge of civil engineering. So you're not just specialised. You understand all the aspects of the consenting and etc. And each, wastewater, stormwater, you've got a good knowledge of it. The third one we've got listed there has a specialty field and is the go-to person on that specialty. So somebody thought that was a good idea. And I do see that working, that somebody might really be good at hydrology and really has that good understanding, it becomes an expert in it. And if somebody in the practice wants to understand more, that's the go-to person you'd go to. And that could be in any field. It could be in stormwater pipe laying. It could be in, retaining wall design, that sort of thing, right? So a specialty field is probably something to aspire to, something that you really interest you and you become really good at. You can think laterally to solve issues. And that's what a civil engineer does. They have issues that come up. How can we mitigate? How can we solve that? And to be able to think laterally. Can make good judgments and compromise. A lot of our work is compromise. You've got the ecologist saying something, you've got the arborist saying something, you've got the client saying something. At the end of the day, it's making those good judgments and being able to compromise to come up with a good solution. Next one was acts within his or her competency. And that's important, that you don't go doing work outside your competency. You go and ask. In any practice, like Beca's or any of the consultants, there's an expert in every field, in every aspect of every field. And there's always a go-to person, right? Has a good mastery of computer tools, and that's pretty important in this day and age. That's something that I haven't really got, a good mastery of computer tools. I'm a drawer. Is good at maths, and this is in all the whenever you look at the requirements for a civil engineer in the educational institutions, they always put an emphasis on maths, particularly trig and calculus. And that's probably good. You've got to have a good understanding of your computer tools, but also of how to manipulate and how they work. Is practical, has lots of common sense. And this was an add-on, and drinks beer both on hot days and cold days. I don't know about that. It has a diverse skill set backed by expertise and knowledge of not only their discipline, but of current regulations, laws, and industry standards. And this guy must have liked the one before and said, and like Chardonnay and sausage rolls, okay? So, okay, so look, and we'll go to the next slide, and I think Joey had a comment on that.
Just my 2 cents. For going through my career, I thought I started off being quite afraid of not asking questions, but that was a mistake. You should, if you're in doubt, absolutely ask plenty of questions, especially now that you're a student and then when you first joined the industry. You ask plenty of questions. And then my other take would be, I guess, don't be afraid to try new things, different things. That could mean anything. But my other one is, well, these are my lesson learned because I didn't do them. Get a mentor in the field. So get a mentor in the field, talk to them, get some advice on what to do next, and maybe their experience that they could share to you, the steps for their career. So it's quite good, I thought. And also search for the value in feedback and criticism. Always ask, how did I do? What are the ways that I could improve? So, yep, that would be from me.
And I would endorse all of those.
Yeah. So again, so we said I'm gonna send this PowerPoint to Edward. I'll have
Yeah.
the Beca watermark removed first, so the students can have them.
Yeah.
So we hope we haven't bored you out and put you off engineering. I hope
think,
the information we presented today gives you some insight of civil engineering and what we do and how to do with them. And also, last but not least, I'd like to thank Edward and
Yeah.
Unitech for giving us this chance to introduce ourselves and Becca to the students. So thank
Yes.
you.
Yeah.
Happy to answer any questions now if you have any.
Just
Yeah.
before you do that, I'd just like to thank you also. There's some aspects we haven't touched on through that. One of them is that when you're designing things, always think of verification. And that's very important in any consultancy, that your work is verified. And that most practices, in fact, all practices, I'm sure, have a system for verification. And that should be done not at the end of the job, but during the design process, so that you don't get to the end of something like those guys did with a retaining wall 16 meters high. Because that was silly, right? And the other aspect that makes a good engineer is to do what you say you're going to do and deliver on time. Now, you can't always do that, but the secret there is to keep your client or your supervisor informed. If you're getting bogged down in something, talk about it, and because people are understanding, and certainly clients, when they're told something, expect it to be done. Okay, that's all for me. Now, if there's any questions, we'd be happy to answer. We've got 7 or 8 minutes.
Yeah. So yeah, you guys, I think good time for me to ask question to Kerry and to Joey.
Johnny, my name is Andy. How are you? Thanks for your wonderful knowledge sharing session. I came in like 5 minutes late while you were introducing the resource consent procedure. I just have a general question. Basically, in your opinion, I would like to know. I understand that from the engineering point of view, we are responsible for delivering designs and client satisfaction. But from the approval point of view, from Auckland Council for the consents, do you think, in your opinion, in your experience, they also require to upgrade their COPs and their process, just so that just to ease the process for the client application for resource consents? I'll be honest. I'll be frank with you on this, because just a simple example which I'm recently working on. I'm working on a project, and that is a brownfield where the client wants to subdivide, and the subdivision process, it actually puts off. It's not only one client, but many of them. Auckland Council has just put a condition on the resource consent, stating that the client has to be is responsible to upgrade the public stormwater drainage. Now you understand. You see what happens is the client, whenever we want to subdivide or something, the client goes. They have a certain budget to get approved from the banks for the loans, and when the resource consents come through, the client was put up a condition to upgrade the stormwater drainage from 225 to 325 because of the runoff, plus the additional 2 manholes and a cesspit. It adds on to 3 or 4% of the costing straight away, and that puts a consultant and the client in a difficult position. As from a consultant point of view, we want the client to be in a profit, be in a good position as well, but then we are also charging them for what we do. If we fail to get the resource consent, then that's where the client gets turned off.
Yeah, well, my response to that would be there could be all options, right? If the pipe must be undersized now to cater for development, right? So if you kept your flow to the down by detention down to the existing flow, then council shouldn't be able to require you to upgrade any system if you're not increasing the flow. So there's always options. The problem with council, if it really did need upgrading and was too small in the first place, it should really be council's requirement. But their answer to that is that we haven't budgeted for that. We're not going to do. We haven't got any money to do that for the next 10 years. So if you're a developer, you're between a rock and a hard place. If you can't solve the problem, then you've got to bite the bullet and do that. And does that make it economic? I don't know.
Yeah, just because the point being is eventually it will be vested to Auckland Council. It's public drainage. It's not the part of the client's responsibility. So it will be vested to Auckland Council. So Auckland Council should be taking responsibility for their own assets, which it's a common sense, to be frank. So what the council is trying to do is I've worked on multiple projects for development, and most of the time I've come across is the developer and the client, and the client or the developer has problems with the council with regards to such conditions in the resource consent. And that is the reason why then we have to again reply for the resource consents, because then they expire within 5 years.
It's pretty typical, right?
Kerry, do you think
you and I are not going to solve their problem?
Kerry, do you think there's an option to negotiate to share cost?
Yeah, look, there's all those sort of possibilities, right? Yeah. And council's first stance will always be, we've got no money to do that.
Yeah, that's typical answer from them. I mean, it's an automated reply, to be honest.
Yeah.
Second, I just had one question with regards to the overland flow path. You were explaining. You explained the depth of. You explained the freeboard was 500. What's the horizontal clearance required from the boundary and the building walls if we have a space constraint?
I think this information you can find through NZS. I don't know. I can't remember on top of my head. But this information you can find through NZS 4404 or the building code E1. I think it might be 1.8 meters.
Yeah, but we have site, because if your depth, we have to keep a depth of. While I was working on when I got it from hydraulic toolbox, that's what I'm using, not using RAS. So from the hydraulic toolbox, it requires that I want to minimize the depth. I want to the limit of the depth to 800.8. That's all I want to keep. And the flow, so the flow I want to keep as at 0.8. So I have to widen my channel in order to suffice that the flow rate. So I don't have much. If I don't have much spacings at the back of the building, is there any condition we have to need to have any clearance from the boundary and the building boundary and the fence, building wall and the fence, if the spacing is 1.4 for the channel, for the flow path?
So are you saying that the channel is
1.4,
not deep enough?
And no, not deep enough, and the width is 1.4.
So you're asking what would be the horizontal
clearance
if the channel is not deep enough?
Yeah.
Is this channel an overland flow path?
It's a designed overland flow path.
Yeah, I think you will need to. Well, what building is this?
It's just a subdivision in brownfield, so just subdividing 2 lots.
So it's a residential.
Residential, yeah, mixed housing zone.
It sounds to me you will need to oblige to the minimum freeboard requirement.
That's fine. So I'm keeping the minimum freeboard for.
But don't you just? 500. Wouldn't you just have to build a wall on the property, on the house side, that was waterproof up to 0.5 meter above the overland flow path level?
But that actually then, if I'm increasing my freeboard above, if I'm keeping my freeboard above the OLFP, it actually restricts me from the height, because I have to maintain the height, understand the height of the building.
I think we've run out of time. Why don't you
Yeah.
put that in an email to
I should do that. Yeah.
an email to Joey, and we'll
Yeah.
try to answer your question. We'll solve your problem for you.
Okay. Yeah. So yeah, thanks a lot.
Thanks for that. Yeah.
Yeah.
think
Any other people got any last questions that you want to ask?
Maybe
Joey
a
and
short
Chris?
question.
Yeah, short question. Yeah. If
Okay.
not, then thank you very much, and then we'll get the PowerPoint and then send to everyone in the class. Yeah,
Okay.
So thank you very much, Joey. Thank you very much, Kerry, for your
Thank you.
That's
presentation.
fine.
So
Yes.
Pleasure to
it's
do
really a
so.
pleasure.
Bye bye.
Okay. Okay. Bye bye. Thanks.
Bye bye.